So, hello everyone. I hope you all are doing really well. So, today we are going to discuss about the very pretty interesting and quite easy problem, that is kth largest element in a stream. So, actually, we have been given this one class, like kth largest class, and we have been given one constructor and one function. So, we need to implement both of these. So, first let us understand the input. What actually we have been given as input, and what we need to calculate as an output. So, let us understand by taking this example here. Okay, so as you can see that this is the kth lab. We haven't given this constructor. Sorry for this so much thickness. Okay, so we have been given this kth. So we have been given this uh, kth largest constructor. Okay, this constructor is taking 3 as an input and this array as input. What is this array? This is actually array nums, and this is actually the value of k we are taking as. Okay, so here the value of k is equal to 3. Now the other is add. So what add is taking? Add is taking a value as an input and a value as an input, like it is taking value as an input 3 and returning what it is returning. So for first the output will be null, of course. First the output will be null. So let me take this output only, and I will show you like how it is coming. So okay, so this will be the output basically of this that particular input. Okay, so how we are taking this coming to this output, let me show you. Okay, so first what is happening is this is kth largest. So this kth largest is taking as an input 3. So I have told you like our value of k is equal to 3. The value of k is equal to 3. Okay, and this is our nums array. This 4 5 8 2, this is the nums array. Now it is obviously returning nothing. It is a constructor because k is largest. Now we have been given this function that we need to complete. Now what add is doing is add is taking 3 as a input value. So when it is taking 3 as an input value, it's adding this 3 value into this array, and also it is returning what add is returning. This add function is actually returning the kth largest element after pushing that particular input value into this array. So here, as you can see, what it add is pushing add is pushing that 3 integer value into this array. So what our array will be? So our array will be 4 5 8 2 and 3. This will be our array. Okay, now this will be our array, and now what is the kth largest element in this array? So as you can see, k is equal to 3. We have been given k is equal to c. So what is the third largest element in this array? So third, the most largest is 8, and then other is fifth, and then other is as you can see, then the other will be 4. So the third largest element will be 4. So here we have our output as 4. Okay, as you can see, 4 as the output. So that's how we are calculating. Let's take another add function. Okay, so our next add function is this. So as you can see, it is taking 5 as an input. This 5 as an input, it is taking this different color. So this add, it is taking this 5 as an input, this 5. So now what it is doing is it just inserting this 5 into this again. Okay, and now what is the third largest element? As you can see, the third largest element is, this is first, this is second, now this is third. So we are not like, this is there are it could not be for like, if it is repeating, then we can take that value also. So third largest is 5 again, so the output will be 5. Now again, what add is taking? Another add is here. Now it is taking 10 as an input. Okay, now it is taking 10 as an input. Let me erase it first. Okay, so there is another add function. Now it is taking 10 as an input, this 10 as an input. So what it will do, it will first insert this in the array. It will first insert this in the array. Let me show you. It will first insert this 10 to the array. Now which is the third largest element in this array? Third largest element will be first largest 8, second largest 3, and again third largest is 5. So it will return 5 as an answer. Okay, now again we have this add function and input value is 9. So again 9 will be like inputted, line 9 will get inserted into this array, and now you can calculate again the third largest element and it will come as 8. So this is how it's happening, and this is how we are calculating the output array. But as you can see, if like we can calculate by this method also, like we can take this array like brute force approach. We can just uh, continue inserting the array sorry values in this array as per the add function, and then we will just sort it out and just calculate the kth largest element from the, like from the AND, the kth element from the and then we will have our answer. But it will be very time consuming, and it will also take more space and time, so it will not be our the optimized approach. So how we are going to solve it? So for solving this one, what we will do is, uh, can you think of some solution, like how you can solve it? Can you think of something? So as I'm learning the heap again and again, like I observe this, that whenever there is a question that actually includes the next larger, next greatest element and these type of questions, then it should click in your mind that it is going to use heap in the solution. Okay, it is going to use heap as a data structure. It is going to, whenever there comes a question of next greater element, next largest element and something like this, so it will use heap as a data structure. Now heap is of two types, one is max and the other is min. So I hope that these concepts are clear. Like you should first understand what is max heap and min heap. Okay, then you should solve this problem. Okay, so and you can just go and search about that what is max heap and min heap. It is quite easy to understand, and I will tell you obviously a little bit while solving the problem. So first, the thing that clicked in your mind after like kth largest and this kind of problem, that it should use the heap. Now what kind of heap it will use? It will use that we need to like understand, and that we need to come as solving this problem. So uh, like clearing your suspense, it will use actually min heap. So why it is using min heap? So for example, if you take max heap, okay, like for example we have this array, okay, if we are going to calculate max heap, then actually you can try, but it will take more of time to solve in case of max heap, and it will not be again optimized. So I'm telling you the solution with min heap, and it is the more better solution. So how we are gonna do this? So just think about it. How we are gonna calculate the kth largest element, for example, and we have been given the k is equal to 3. Okay, we have been given k is equal to what? 3. So if the heap size is 3, for example, if our heap size will be 3, like this is our heap size, for example, if our heap size will be 3 and the topmost element, in mean heap the topmost element is minimum. Okay, so if our heap size will be 3, for example, I am taking this number 4, 5 and 2. ठीक है, I am taking this array, for example, these three numbers. So which is the for example, which is the third, like 4, 5, 2. Let me take one other number, like I am taking 1. Okay, I am taking this array. Now which is the third largest element in this particular scenario? So you can guess it, like third largest will be 2. Okay, so if we are taking let okay, so let me just clear this one, because I'm thinking like I can tell you more in a more good manner if I have this 3 number only. Sorry for this inconvenience. Okay, so I have taken this 4 5 to these three these three numbers. Okay, so how do I calculate the third largest number? So if I have these three numbers, then if I will convert it into min heap. So the third large 2 will come here because it is the minimal, and 5 4 and 5. Okay, so the third in min heap, if min heap of size 3, so the topmost element will be the third largest element, as you can see. Okay, erase that. Okay, so as you can see, the third largest element is the topmost element if we have the size of 3 as the min heap. Okay, so now if you want to add, for example, 1 in this array. Okay, and so if you want to add 1 in this array, so now what will be the answer? Will remain same. What will be the answer? Answer will be 2 again. Like, what will be the third largest element? It is 2 again. If you add 1 to this array, it will be 2 again. But if you add, like for example, if you add 6 to the array, now what will be the third largest? So if you add 6 to the array, so what will be third largest? 6 5 and 4. Now the third largest will be 4. So how you're gonna calculate this? With the help of heap. So if you have, for example, 6, you are going to add 6, so you take 6. Now you see, like, okay, 6 is greater than the topmost element. So what you will do? 6 is greater than the topmost element, so what you do? You just push this 6 into the heap, and such that the size of the heap should remain the, like, 3. So what you will do? You just pop this topmost element out, and just push this 6, you just pop this element out, and you just push this 6 into this into that particular heap. Now when you push this into heap, what will happen? This is 6 4 and 5, but it is not min heap. So what will happen? It will, like, heapify. If you don't know what is heapify, so it will just do the heapify process, and it just convert itself into the min heap. So after converting into the min heap, what will be the answer? It will be 4 5 and 6. So now what is the topmost element? The topmost element is 4, so it will be the third largest element. So as you can see how we are doing it. If whenever we are inserting the new array element into the array, we just check. For example, we have inserted this 1. Okay, first we have inserted this. Let me take another color. First we have inserted this 1 number. So when we have taken 1 number, it is smallest than this 2. So it is smallest than 2. That's why our whatever our third largest element, it remains the same, that is 2. But whenever we are adding something that is greater than 2, then the third largest element actually changes. Okay, so whenever we are adding something that is greater than the topmost element, that we need to do? We need to pop the topmost element, and we need to insert the new element, and then we need to heapify this structure. Actually it will heapify itself because it's a min heap, and then whatever the topmost element, we need to return that. Let us take another example that is actually given in the question itself. Let us take this example. Actually, I hope it's been clear in your mind that how we are actually implementing this algo. Okay, so now again let us take the example of the question itself. So we have been given 4 5 and 8 2. 4 5 and 8 2. Okay, so we need to maintain the size of the heap as 3 because k is equal to 3. Okay, so for example, 4582, it is 4582. Now if we just maintain this heap structure, so what will happen? 8 will it will be like a 3 like structure. So we'll just make a 3, like k is 3, so we'll make the min heap which has size 3. So if we make the min heap out of this, so it will be like 4 will be here, 5, and this will be 8. Okay, I hope that makes clear, because k is equal to 3, so we will take 3 largest elements up to there and we make the min heap. Now add 3. So whenever we need to add 3 into this array, so whenever we are adding something like this 3, so what we will do, so we will see, first we will see, okay, is 3 greater than 4? No, 3 is lesser than 4. So if 3 is lesser than 4, we will do nothing. We just return the topmost element of the heap. So what is the topmost element? 4. So we just return 4, and you see, like, the first output is 4. Okay, now again, okay, sorry, okay, so now again what will happen, the another add function is there. Okay, so this add, now it will add what, it will add 5. Okay, so it will add 5. Now we will take 5. So we check, is 5 greater than or smaller than the topmost element in the min heap? So 5 is greater than the topmost element in the min heap, and whenever the element which we are adding is greater than the topmost element in the min heap, we just pop the topmost element and then we insert this element into the heap. So what will happen, it will just, like, it will become, the heap will become like this, 5 5 8. Now as you can see, it is already a min heap, so we don't need to make any change. Now what will, now we will return this topmost element of the min heap, so we will return 5. So as you can see, we have 5 here. So that's how we are using this heap to actually implement the solution, and to implement the solution. Okay, now let us take another example if you are not able to understand it still, but I hope you are able to understand now and you are able to calculate the another output yourself. So when we add this 10, so now what is 10, like, is 10 greater than or less than, is 10 greater than or less than, like here we have 5 actually. Okay, so is 10 greater than or less than 5? 10 is actually greater than 5. So what we do, we just pop this 5 out and push this 10 inside it. So what will happen, 10, 5 and 8. Now we just heapify it, and after heapifying it, what will happen, this, after heapifying it, what, like, what will happen, after like 10 is actually greater than this, so after heapifying, what will happen, 5 will come at the top, 8 and this 10. So we just return what, we just return the topmost element in the min heap, so we return 5, and you can see here we have our 5 as an answer. Sorry for this overlapping. So I hope this will make clear understanding in your mind about the conceptual clarity, about the conceptuality of this question. Now the other thing is, what is the time complexity? So as you can see, the time complexity is, we are pushing inside, so whenever we are inserting something and popping something out, so it will take log n time, because it will that heapify again, so, and the level in the heap is will be log and so n levels. So but here we have only 3 elements, so it will be like log k, so it will take like log k, time it will take. Okay, it will take log k time, its time complexity will be log k. And how many times we need to do this, it, in the worst case scenario, it will be, I guess, n log k. So in the worst case scenario, it will be n log k, so that will be answer in the, for the worst case. This is the time complexity. And for space, it is only taking k space, okay, because we are storing the we are just taking the k elements in our heap, so it is taking OK space. So I hope this is clear in your mind. Now let us look at the code first. Okay, so this will be a major confusion, like in between max and min heap, that how we actually declare the max heap and min heap. So we actually implement heap with the help of priority queue. If you don't know priority queue, just Google it, or ask to ChatGPT also, or you can find a solution, find the priority queue description in YouTube also. So how we just implement this, we implement min heap or max heap with priority queue. So I will make another video describing this, but whenever we just declare priority queue, so it will implement max heap as default. But if we just put this comparator, like this greater int comparator, so it will actually declare, it will actually implement min heap. Okay, and then how this greater int comparator function and what is it all about, so we will discuss it in later videos. Now what will happen, we just for every num element we add, we actually for every element in this vector we actually add this element into our array. Okay, and whenever we are applying this add, we make sure that the heap size should not exceed, the value k. So it, we will make sure that. And now if if it does not exceed the size, then we just push the value inside the heap, and if it exceeds the value, then we will check if the topmost element is greater than or less than the value. And then we, if it is less than, then what we will do, we just, if it is less than the value, we just pop it, this value out, the topmost element, we just pop this out. As you can see here, we actually popped it out and inserted this new value into the heap. Okay, and as it is min heap, it will maintain by its internal structure as min heap. So that's how we are doing it. And after that, add will return the topmost element, which is the kth largest element in the array. So that's how we are implementing this, and I have already submitted the solution, and it's actually successful, a successful solution. So I hope I will be able to, I actually able to understand, elaborate this question clearly. If you have any doubt, you can write in the comment section and we will learn it together. Thank you for watching.